Good morning. Today, I want to shed light on a connection that many overlook. The vital link between your gut and your brain, specifically your memory. You might think memory loss is purely a brain issue. It's not. Research is increasingly clear. The health of your gut has a powerful influence on how well your brain performs, especially in memory retention and recall. The gut and the brain are in constant communication through what is known as the gut-brain axis, a complex, bidirectional network that involves neural, hormonal, and immunological signaling. This axis allows for the continuous exchange of information between the gastrointestinal tract and the central nervous system. At the heart of this connection is the vagus nerve, the longest cranial nerve in the body, which acts like a high-speed cable transmitting messages back and forth between the gut and the brain. But the gut-brain axis goes beyond just nerve signals. It includes a wide array of biochemical messengers including neurotransmitters, cytokines, and metabolites produced by gut microbes. This intricate system means that what happens in the gut doesn't stay in the gut, it echoes in the brain. One of the most remarkable aspects of this relationship is the role of the gut microbiota, the vast community of trillions of microorganisms residing in the digestive tract. These microbes play an essential role in producing key neurotransmitters like serotonin, dopamine, and gamma-aminobutyric acid, GABA, all of which are involved in regulating mood, cognition, and memory. In fact, nearly 90% of the body's serotonin is synthesized in the gut. When the gut microbiome is healthy and diverse, it supports optimal brain function. However, when this delicate ecosystem is thrown out of balance, a state known as dysbiosis, it can lead to significant disruptions in mental clarity, memory formation, and emotional stability. Dysbiosis can trigger inflammation not only in the gut but also systemically. When the intestinal lining becomes compromised, a condition sometimes referred to as leaky gut, it allows harmful substances such as endotoxins and undigested food particles to enter the bloodstream. This breach activates the immune system, which in turn releases pro-inflammatory cytokines. These inflammatory molecules can cross the blood-brain barrier, the protective shield that normally keeps harmful substances out of the brain. Once inside, they can contribute to neuroinflammation, a key factor in cognitive decline and memory impairment. Moreover, gut health influences the brain's plasticity, its ability to form and reorganize synaptic connections, especially in response to learning or after injury. Certain gut bacteria produce short-chain fatty acids, SCFAs, such as butyrate, which have been shown to support the growth of brain-derived neurotrophic factor, BDNF, a protein critical for long-term memory and learning. A compromised microbiome, therefore, can hinder the production of SCFAs and reduce levels of BDNF, impairing the brain's ability to retain and process information effectively. This connection also explains why individuals with gastrointestinal disorders often report mental symptoms such as brain fog, poor concentration, and forgetfulness. Conditions like irritable bowel syndrome, IBS, and inflammatory bowel disease, IBD, are frequently accompanied by anxiety, depression, and memory issues, underscoring how closely linked these two systems are. The gut, sometimes referred to as the second brain, houses its own nervous system, the enteric nervous system, which can function independently but is also tightly intertwined with the central nervous system. This dual control enables the gut to send powerful signals that shape our mental and emotional landscape, including how well we remember, learn, and focus. The gut microbiome is a diverse and dynamic community of trillions of microorganisms, including bacteria, viruses, fungi, and other microbes, residing primarily in the large intestine. These organisms play an integral role not only in digestion and immune function, but also in regulating mental and cognitive health. A key way in which the microbiome influences the brain is through the production of vital neurochemicals and metabolites that directly affect neurological processes. Among the most important of these are neurotransmitters such as serotonin, gamma-aminobutyric acid, GABA, and dopamine. While many people assume these brain chemicals are produced solely in the brain, a significant portion, especially serotonin, is actually synthesized in the gut. This reveals the far-reaching influence of the microbiome on mood, emotional regulation, and memory function. Gut bacteria also produce short-chain fatty acids, SCFAs, such as butyrate, acetate, and propionate, through the fermentation of dietary fibers. These SCFAs serve multiple purposes. They maintain the integrity of the gut lining, reduce systemic inflammation, and influence the activity of the central nervous system. Butyrate, in particular, has neuroprotective properties. It can cross the blood-brain barrier and enhance the expression of brain-derived neurotrophic factor, BDNF, a key protein that supports neuron growth, synaptic plasticity, and long-term memory formation. Low levels of butyrate and other SCFAs have been associated with decreased cognitive performance and a higher risk of neurodegenerative diseases. When the microbiome becomes imbalanced, a state known as dysbiosis, the production of these beneficial neurotransmitters and metabolites is disrupted. Dysbiosis can be caused by several factors, including poor diet, chronic stress, antibiotic use, and environmental toxins. In this altered state, the gut may produce fewer supportive neurochemicals while allowing the proliferation of harmful bacteria that generate pro-inflammatory substances. These inflammatory byproducts can enter the bloodstream, reach the brain, and trigger neuroinflammation. This type of inflammation has been implicated in brain fog, reduced focus, and memory lapses. Emerging research continues to show a strong connection between gut microbial diversity and cognitive performance. Individuals with a richer and more diverse gut microbiome tend to perform better on memory tasks and exhibit fewer symptoms of cognitive decline. Conversely, a reduction in microbial diversity is often seen in individuals with neurodegenerative conditions such as Alzheimer's disease. This suggests that nurturing the microbiome may be a protective factor against age-related memory deterioration. The microbiome also interacts with the hypothalamic pituitary adrenal (HPA) axis, which governs the body's response to stress. A balanced microbiome can help regulate this axis, keeping stress hormones like cortisol in check. Chronic elevation of cortisol has been linked to impaired memory and shrinking of the hippocampus, the brain region responsible for forming and retrieving memories. By supporting a healthy microbiome, it is possible to mitigate the negative cognitive effects of stress. The cumulative evidence strongly suggests that the gut microbiome is not just a passive resident of the digestive tract, but a key player in maintaining cognitive health and preventing memory-related disorders. Inflammation is a natural immune response designed to protect the body from injury or infection, but when it becomes chronic and systemic, it can have damaging effects, especially on the brain. One of the most significant ways this happens is through a condition commonly referred to as leaky gut, or increased intestinal permeability. In a healthy gut, the intestinal lining acts as a selective barrier, allowing nutrients to pass into the bloodstream while blocking harmful substances like toxins, pathogens, and undigested food particles. However, when this barrier is compromised, it becomes porous, allowing these unwanted substances to enter the bloodstream and trigger widespread inflammation. Once these inflammatory molecules, such as lipopolysaccharides, LPS, cytokines, and other endotoxins, circulate through the body, they can reach and affect distant organs, including the brain. The brain is protected by the blood-brain barrier, a tightly regulated structure that shields neural tissue from harmful substances in the blood. But under chronic inflammatory conditions, this barrier becomes compromised. When the blood-brain barrier is weakened, inflammatory agents can infiltrate the brain, leading to a condition known as neuroinflammation. Neuroinflammation disrupts normal brain function and has been associated with a range of cognitive issues, including impaired memory, poor concentration, and slower processing speeds. The hippocampus, a critical area of the brain responsible for learning and memory, is particularly vulnerable to the effects of inflammation. When exposed to high levels of inflammatory cytokines, neurons in the hippocampus become less responsive and may even degenerate over time. This leads to a decline in synaptic plasticity, the brain's ability to form new neural connections and reorganize itself in response to learning or experience. Neuroplasticity is essential for encoding new memories, adapting to new situations, and recovering from injury. Chronic inflammation reduces this adaptability, making it harder for individuals to learn, retain information, or recover from cognitive decline. Furthermore, inflammation alters the production and function of key neurotransmitters like serotonin, dopamine, and acetylcholine, which are essential for mood regulation, attention, and memory. For example, pro-inflammatory cytokines can interfere with the conversion of tryptophan into serotonin, redirecting it toward the production of neurotoxic metabolites instead. This imbalance contributes not only to mood disorders like depression and anxiety, but also to difficulties with memory and focus. Inflammatory processes also disrupt mitochondrial function, reducing the brain's ability to generate energy efficiently. Since the brain is one of the most energy-demanding organs in the body, this impairment can significantly affect mental clarity and performance. Diet and lifestyle factors play a critical role in either promoting or preventing this inflammatory cascade. Diets high in processed foods, trans fats, and refined sugars have been shown to contribute to leaky gut and systemic inflammation, while nutrient-rich, anti-inflammatory diets can help restore gut integrity and protect the brain. Reducing chronic inflammation through gut health is a vital and often overlooked strategy for preserving cognitive function and enhancing long-term brain resilience. The connection between gut health and brain function is far deeper than many people realize, and the signs that your gut may be impacting your cognitive performance are often subtle at first. When the gut is not functioning optimally, it sends out a variety of distress signals, not just in the digestive system, but throughout the entire body, including the brain. These signs can easily be overlooked or attributed to unrelated issues, but when examined together, they often point to a disruption in the gut-brain axis. Common digestive symptoms like bloating, gas, or irregular bowel movements are usually the first indicators that something is amiss. Bloating after meals may suggest fermentation or imbalance in the microbial population, while constipation or diarrhea can reflect an impaired gut lining or inflammation. These physical signs often coincide with systemic symptoms such as unexplained fatigue, which may not immediately seem related to gut health but often results from impaired nutrient absorption and chronic low-grade inflammation originating in the gut. When the body is constantly battling gut-based inflammation or dealing with poor digestion, it uses more energy on defense and repair, leaving less available for cognitive tasks. Beyond the gut itself, cognitive and emotional symptoms frequently arise when the digestive system is compromised. Individuals may begin to notice difficulty concentrating, lapses in short-term memory, or a general sense of mental fogginess. These symptoms can be frustrating, especially when they occur in people who are otherwise physically healthy. The reason behind this mental sluggishness often lies in the biochemical and inflammatory signals sent from a disrupted gut microbiome. An imbalanced gut produces fewer beneficial neurotransmitters like serotonin and GABA, while potentially increasing the production of neurotoxic compounds. This imbalance can cause the brain to function at less than full capacity. Food sensitivities are another red flag. If someone starts reacting negatively to foods they previously tolerated well, experiencing headaches, skin issues, or digestive discomfort, it may suggest a compromised gut lining or an overactive immune response triggered by dysbiosis. These food reactions can worsen inflammation and further stress both the gut and the brain. Additionally, the immune response to food particles that cross a leaky gut barrier can elevate systemic inflammation, which is known to affect mood and mental clarity. Mood swings, anxiety, and even mild depression can also stem from disturbances in gut health. As most of the body's serotonin is produced in the gut, a struggling digestive system can have profound effects on emotional stability. Poor sleep quality often accompanies these changes, further exacerbating memory issues and decreasing cognitive sharpness. Sleep disturbances, coupled with poor digestion, create a cycle that is difficult to break without addressing the root cause, the gut. Recognizing the pattern among these symptoms, digestive irregularities alongside mental and emotional difficulties, can provide a valuable clue that the gut may be influencing brain health. These signs should not be dismissed as isolated or unrelated, but rather understood as interconnected signals from the gut-brain axis calling for attention and care. What we eat has a profound effect on the health of our gut and, by extension, the function of our brain. Unfortunately, many modern diets are filled with substances that damage the delicate balance of the gut microbiome and contribute to inflammation, both of which can impair memory and cognitive performance. Among the most harmful to gut health are highly processed foods, which are often stripped of natural fiber and loaded with additives, preservatives, and artificial ingredients. These foods provide little to no nourishment for beneficial gut bacteria, starving them of the nutrients they need to thrive while creating an environment that favors harmful microbes. This imbalance, known as dysbiosis, disrupts the production of key neurotransmitters and impairs the gut-brain communication network. Refined sugars are another major offender. They quickly spike blood sugar levels, leading to a surge in insulin and a subsequent crash in energy. More importantly, excessive sugar consumption promotes the growth of inflammatory bacteria and yeast in the gut. These changes in the microbiome can trigger an immune response that leads to systemic inflammation, including inflammation of the brain. This kind of neuroinflammation has been associated with slower mental processing, poor memory recall, and even structural changes in regions of the brain linked to learning and memory, such as the hippocampus. Furthermore, sugar-induced inflammation can damage the gut lining, contributing to increased intestinal permeability and allowing harmful substances to enter the bloodstream. Artificial sweeteners, often marketed as healthier alternatives to sugar, can also negatively affect gut health. Substances like aspartame, sucralose, and saccharin have been shown to alter the composition of the gut microbiota, reducing microbial diversity and impairing glucose metabolism. These artificial compounds may not provide calories, but they still interact with gut bacteria in ways that can disrupt balance and lead to the same inflammatory outcomes as sugar. Additionally, some artificial sweeteners can have neurotoxic effects, contributing to mood instability, headaches, and cognitive issues when consumed regularly. Excessive alcohol intake is another major contributor to gut and brain dysfunction. Alcohol can irritate and inflame the gut lining, making it more permeable and allowing harmful substances to leak into the bloodstream. It also disrupts the balance of gut bacteria, promoting the growth of pathogenic strains while killing off beneficial ones. The result is a compromised gut barrier and increased systemic inflammation, both of which are damaging to the brain. Chronic alcohol consumption has been linked to memory loss, reduced cognitive flexibility, and diminished executive function. These dietary choices not only harm the gut microbiome but also contribute to long-term declines in mental sharpness. The inflammation they trigger can interfere with the production of brain-derived neurotrophic factor, BDNF, a key molecule involved in memory formation and synaptic plasticity. Lower levels of BDNF make it harder for the brain to form new connections and retain information. Over time, these dietary habits can accelerate cognitive decline, making the gut-brain connection a critical factor in the preservation of memory and mental performance. Healing the gut and improving memory can often begin with the foods we choose to include in our daily diet. Certain natural nutrient-dense foods have powerful effects on both the gut microbiome and brain function, working to restore balance, reduce inflammation, and enhance cognitive clarity. Among the most effective are fermented foods, which provide a rich source of live beneficial bacteria. Foods like yogurt, kimchi, sauerkraut, kefir, and miso are packed with probiotics, microorganisms that help repopulate and diversify the gut microbiota. These good bacteria aid in digestion, strengthen the intestinal lining, and communicate directly with the brain through the production of neurotransmitters like serotonin and GABA. By improving microbial balance, fermented foods play a direct role in reducing symptoms such as brain fog, mood swings, and forgetfulness. Prebiotic-rich foods also support a healthy gut-brain connection. Unlike probiotics, which are live organisms, prebiotics are types of fiber that feed the beneficial bacteria already present in the gut. Foods such as onions, garlic, leeks, asparagus, and bananas provide the necessary nourishment for these microbes to thrive. When digested, prebiotics are fermented in the colon, leading to the production of short-chain fatty acids like butyrate. These compounds not only help maintain the integrity of the gut lining but also support anti-inflammatory pathways and stimulate the release of brain-derived neurotrophic factor, BDNF, a key protein involved in memory and learning. A diet rich in prebiotics helps create a gut environment conducive to optimal mental function. Omega-3 fatty acids are another essential component in the effort to improve gut and brain health. Found in fatty fish such as salmon, mackerel, and sardines, as well as in plant-based sources like flax seeds, chia seeds, and walnuts, omega-3s are well known for their anti-inflammatory properties. These fatty acids help reduce both gut and brain inflammation, supporting the health of neuronal membranes and improving communication between brain cells. Regular intake of omega-3s has been shown to boost memory, concentration, and even mood regulation. Additionally, omega-3s support the integrity of the gut barrier, reducing the risk of leaky gut and the systemic inflammation that follows. Polyphenol-rich foods round out the group of healing dietary choices that benefit both the gut and the brain. Polyphenol are naturally occurring plant compounds with antioxidant properties that protect cells from oxidative stress and inflammation. Foods such as blueberries, green tea, dark chocolate, turmeric, and colorful vegetables are excellent sources. These compounds help modulate the gut microbiota by encouraging the growth of beneficial bacteria and inhibiting harmful ones. In the brain, polyphenol enhance blood flow, support synaptic plasticity, and have been linked to improved memory performance and a lower risk of cognitive decline with aging. Blueberries, in particular, have demonstrated measurable effects on delayed memory and cognitive speed in various studies. Incorporating a variety of these gut-friendly, brain-supporting foods into the daily diet creates a foundation for long-term mental clarity and emotional balance. Their combined effects work synergistically to heal the gut lining, reduce inflammation, support healthy neurotransmitter production, and reinforce the gut-brain axis, ultimately leading to improved cognitive performance and sharper memory.